Okay, so today we're going to be doing a linear and multiple regression analysis to see if there is a relationship between one variable and another. So let's say, for example, that we have a table like this wherein we have the price of the houses, and this price of the houses are basically dependent, and we want to check if they're basically dependent on like the size of the house in square feet, the number of bedrooms, the how old the house is, and the distance to the city. So what we can do first is we can take any one of these variables. So let's say, for example, the distance to the city. We want to check if whether or not there is a relationship between this and this. So what we can do is we can just highlight all of this, go to our insert tab, click on our recommended chart, take a scatter plot diagram, and with this you can see that there is an inverse relationship between the price of the house and the distance to the city. Basically, as the price of the house goes up, the distance to the city gets smaller. You can see this here, for example, when this house is 22 miles from the city and it only costs 150,000, as opposed to this house being 450,000 and it's only 1 mile to the city. And this basically just shows that the trend wherein that there is an inverse demand function. As one goes up, another one goes down. We could even just click on any one of these dots over here. You right click and you add a trend line, and this basically shows you how there's basically an inverse relationship between this variable and this variable. So let's say now that we want to find the linear regression model. We'll go to our data tab, and from our data tab we can go to our data analysis. If you do not see this option over here, you come to file, you go down to options. From options you go to add-ins, from add-ins Excel add-ins, and you press go, and you click on this one. Mine is already selected, so you can just click on that and you can press OK, and this should appear over here. So you do that and you click on data analysis and you come all over here. With this data analysis, you can do basically the correlation, covariance. You can do an F test and all this other stuff, a T test, a Z test. But now we're going to be doing a regression over here. So click on regression, press OK. And now for our regression, we have the input Y range and the input of X. Now your Y is your dependence variable and your X is your independence variable. So what we want to see is which one of these is our dependent variable. But what we're trying to do is to see whether or not the price depends on the distance to the city. So as a result of that, your Y becomes your dependence variable, which is actually the sale of the house. So what you can do is you can just highlight all of this for your Y range, and your independence variable, which is the distance to the city, you can just highlight all of this. And you can click on labels and worksheets and you can press OK. Now this is what we're going to have as our regression analysis. So what we have is we have the multiple R and the R squared. What you want to focus on over here is your R squared, and we can see that as R squared of 0.75 basically tells us that there's a 75% chance that the price of the house is as a result of the distance to the city. So there's a 75% chance of that. The adjusted R squared, we're not going to be looking at that right now since we're just doing a simple linear regression analysis. And for simple linear regression, we just did one variable to another. We'll do a multiple regression soon. We have a standard error of 43,551. This tells us how far these dots are far from the regression line. So the smaller this value is, the more precise your data analysis is going to be. We have a significance f, which is basically a p-value, which basically tells you the probability of this just happening by chance, the probability that the distance to the miles has an effect on the price of the house, which is basically telling you if it's random or not. And we can see that this value has to be less than 0.05, and it clearly is because this is E-07, which basically means 1, 2, 3, 4, 5, 6, 7 zeros before we have our 557,081. So this will be 0.0000, and that is definitely less than our 0.05. Okay, so now let's see how we can do a multiple regression analysis. What we did here was a simple regression analysis. Basically, we regress one variable on another to see if there's any relationship. Now we can do a multiple regression analysis. So let's say, for example, we want to see whether or not all of these variables, the size, number of bedrooms, how old the house is, and the distance to the city have an effect on the price of the house. So again, we go to our data tab, we go to data analysis, click on regression, and for input y range, which is our dependence variable, this will be the sale of the house as usual. Just highlights everything else. And then now for our x range, for x, we want, this is our independent variable. So this will be all of these variables over here, the size, bedrooms, age, and distance to the city. So just highlight everything over here, put in the labels, and we click on OK. So this will be our regression statistic. And we can see now that it has gone up significantly. Our R squared is now 97, well, 97.9%, basically 98%, and it's gone up from 75%. And now we're not exactly going to be looking at our R squared, but our adjusted R squared, because this is adjusted for the other variables. And we can see that there's a 97.4 chance that all of this happened by chance. So this has gone up from 74%. And our standard error, basically the distance the scatter plot shows from the regression, from the trend line, has gone down significantly. The first linear regression we did, we had like 43,000, and now we have in 13,000. Basically, this tells us that the smaller it gets, the more precise it is. We have our p-value over here of basically having 12 zeros now, basically telling you that there is no way this is happening by chance. So this is how you do your regression statistic. This is how you interpret the results.